Hi, today I would like to talk about how an X-ray scanner works. The other day I was at the airport and there was this X-ray scanner which was used for checking for any suspicious items in a bag, and the electronic items were also checked separately. So the items were segregated into two trays, and in one tray a bag was kept with certain contents in it. The other tray was exclusively for electronic items like laptops, iPads, mobile chargers, mobile phones, etc. These two trays would enter into the X-ray scanner one after the other. Once the trays enter the scanner, first let's see what happens to the bag. There are all kinds of X-rays: low energy X-rays, high energy X-rays that strike the bag first and pass through the bag. Out of all the X-rays which have struck the bag, it will be the low energy X-rays which would be sensitive to those contents which are majorly made of organic matter, that is carbon. And I say this because generally those elements which have less number of electrons will be sensitive to low energy X-rays. The organic material mostly consists of carbon, and the carbon consists of only 6 electrons, which is low number of electrons. Even out of the low energy X-rays which are sensitive to the organic matter, some of the X-rays have less energy than the others. So normally the explosives are made up of long chain carbon molecules, and these kind of items would be sensitive to the low energy X-rays. And what I mean by sensitive to low energy X-rays is that the X-rays would be scattered by the elements of this material, scattered in all directions. Whereas items like steel knives and handguns, they're majorly made of iron, and iron has a high number of electrons. Iron has 26 electrons, and these materials will be more sensitive to high energy X-rays, which means they will scatter more of high energy X-rays. After striking the bag, the high and the low energy X-rays then pass through a plate which is called a detector beneath the bag. And this plate is made up of two semiconductors, in between which is a pure thin metal. What I mean by a semiconductor here is that it has an ability to conduct, but it does it in certain conditions. When it's given enough energy, the electrons in the material of the semiconductor move to high energy levels, and then the semiconductor conducts. And that's why, since it conducts, but it does so in certain conditions, it's called a semiconductor. As I told you, in the X-ray scanner, there is a detector beneath the bag, and the detector, as I told you, that it consists of two semiconductors. The X-rays that have passed through the bag, that have been scattered by the bag, strike the first semiconductor. Now the electrons in the material of the semiconductor, which are at a certain energy state, get some energy because it is the X-rays which have struck the plate. The X-rays which are having a high energy have given energy to the electrons of the material of the semiconductor. When the scattered X-rays and the X-rays that have passed through the bag have struck the first semiconductor, the electrons of the material of the semiconductor receive energy. Initially they are at a certain energy level, and after receiving the energy they jump to a higher energy level. They jump to an energy level in a band that is called a conduction band. Initially, the electrons in the material of the semiconductor are in a band called valence band. After getting energy, they enter into the conduction band. Once the electrons have entered the conduction band, they've also left behind spaces at positions they have formerly occupied, and these spaces are called holes, and they are thought of to be positively charged holes because there is a lack of electron. Wherever there is a lack of electron, you say that the element is positively charged. As the X-rays from the bag keep striking the first semiconductor, there will be accumulation of holes and electrons. And these electrons and holes are pulled to either side of the semiconductor using a small inbuilt electric field. Now, by being able to measure the amount of charge that has been pulled to either side of the semiconductor, one can get information about the kind of X-rays that have struck the first semiconductor in the first place. There's also one more point that I would like to say here, and that is the first semiconductor is such that it is able to scatter only the low energy X-rays. The X-rays that have struck the first semiconductor plate then pass through the thin metal in between the two semiconductors. The setup of the whole detector that I've mentioned before. The function of the metal here is that it filters the low energy X-rays and only lets through high energy X-rays that then strike the second semiconductor beneath the thin metal. The high energy X-rays strike the second semiconductor, and the same procedure regarding the accumulation of electrons and holes occurs, and the information about the kind of high energy X-rays is extracted. And depending on the intensity of the different high energy X-rays, the X-rays are color coded. So from the first semiconductor, you have information about both high energy and low energy X-rays. From the second semiconductor, we have information about high energy X-rays. Both these informations are compared. From this comparison, one can extract the number of low energy X-rays that was scattered by the bag. So out of this entire exercise, we got two kinds of information from the two semiconductors which form the detector plate. And these two pieces of information are vital because, as I told you before, the materials like explosives are made of long chain carbon molecules, and carbon has less number of electrons and they scatter low energy X-rays. The items like steel knives and handguns are made mostly of iron, and the element iron consists of high number of electrons and they scatter high energy X-rays. By understanding the nature of the various energies of X-rays, one can get an imaging of the items that are inside the bag. So the first tray is scanned, that consisted of the bag. The second tray consists of electronic items like laptops, tablets, mobile phones, chargers, etc. One could easily wonder that is it because the items which are placed beneath an electronic item like a laptop, would they be shielded by the metal of the laptop from getting probed by the X-rays? Because as I told you, the metal in the detector plate was able to filter out the low energy X-rays, and the information about the low energy X-rays is vital. It is vital because it checks if there are any explosives or other such items. But most likely it's no. It's not because the casing of the laptop is made of metal. Most of the times the casing of the laptops are made of plastics or a kind of metal which has less number of electrons, that is aluminum. Aluminum is one of those metals that have less number of electrons, 13 electrons. So if it has nothing to do with the kind of material of the casing of a laptop or any of the other electronic items, why is it that there is a separate check for these electronic items? The answer is the interior parts of the electronic items are so small and they're so large that itself warrants that it requires a separate check. I hope that you understood how the X-ray scanner is able to image the contents inside a bag and also inside electronic items. Before leaving, I would like to stress one more point. In some X-ray scanners, it is not the X-rays which directly strike the bag or the electronic items, but rather it is a flash of light. What happens is X-rays are passed through a kind of a plate called a scintillator plate, which converts these X-rays to a flash of light, and then this flash of light strikes the bag or the electronic items.